Okay, welcome back guys. My name is Talha Khan and today we are in the second section of our first module of the course Data Science, a Naive Man's Approach. Now this is the second section where we'll be learning about probability and distribution. So don't worry, you don't have to do those confusing mathematical problems of probability that you probably would have done in your school days. So let me quickly introduce you with the concepts that we are going to cover in this section. There will be three major concepts. First is the probability concepts, then distributions, then few miscellaneous important concepts. In probability concepts, we'll start by understanding sample space and events, then methods of assigning probability, then the types of probability, then we'll cover Bayes' theorem, then we'll cover probability density functions. Then under distributions, we'll see binomial distribution, normal distribution, Z-score and its use, T distribution, chi-square and F distribution.
Then under the important concepts, we'll see odds and log odds.
Then confidence interval, then population proportions, and finally we'll cover central limit theorem. So this is how the section will look like. Now without further ado, let's get started with our first concept, that is probability concepts. Now to understand probability, we should know what is sample space and event. So basically sample is the set of all possible outcomes and it is denoted by S. Then event is the subset of sample space and it is denoted by E. Now probability is the likelihood of an event and it is given by number of ways anything can happen or number of events in favor divided by total number of outcomes or total number of events. Now let's see each of these with an example. So we will see the classical case of flipping a coin. You flip a coin once. So what are the possible outcomes? Either a head or a tail. So this will be our sample space, which is the set of all possible outcomes. Now we wish to find the probability of head. So head and tails are two possible outcomes, which are a subset of our sample space. Hence these are called events. So we have two possible events. Finally, probability of head can be calculated simply by using the above formula, that is events in favor is equal to 1 and total number of events is equal to 2. Therefore, probability will be 1 by 2. So this was pretty straightforward. Now let's say we flip the same coin twice. So the possible outcomes would be first flip of coin gets head and second gets tail. Second could be both flips get heads. Third could be both flip gets tail. And last fourth one would be tails on the first flip and heads on the second flip. So these are the only possible outcomes. Hence this will be called as sample space. Now event would be its subset, which could be head or tail, or head or head, or tail or tail, or tail or head. And the probability will be given as follows. Let's say for the event head tail, it would be 1 by 2 into 1 by 2 is equal to 1 by 4. Because in each flip, event in favor would be 1 and total events would be 2. And we have flipped the coin twice. So it will get multiplied. So that is what sample space, event and probability are. Now all the possible events put together are called collectively exhaustive events, which basically equals to the sample space. Then the second toss of the coin is not dependent on the first toss. Hence such events are called independent events. Similarly, we can get either head or a tail. So both cannot happen at the same time. And this is called mutually exclusive events. Now let's say we are interested in finding the probability of the event in which we get tail as the outcome of both the tosses. So our event is tail-tail in both the flips. And rest of the events are called complementary events. So these were few basic definitions. Now let's move on to the next topic. So here we will see different ways of using probability. Now you really don't have to remember this. This is just to make you acquainted with the concepts. So first we have classical probability, which is given by the number of events in favor divided by total number of events. It is computed before the experiment and also called as priori, such as computing the probability of getting the number 5 on rolling a 6-sided dice. Then we have relative frequency probability, which is computed after an experiment. So basically where we cannot apply the theoretical probability and have to run the experiment, such as probability of rain using the past data, etc. That is called relative frequency probability. It is given by number of times event has occurred divided by total number of trials. And the third one is subjective probability, which is basically intuition or reasoning, such as expert advice for site selection for opening a restaurant or introducing a product based on its requirement, etc. Now there are 4 types of probabilities. First is marginal probability, which is basically classical probability that we just saw. Then we have union, which means probability of occurrence of x or y and is given by the formula probability of x plus probability of y minus probability of x and y. This is called law of addition of probability. Then we have joint probability, which is the opposite of the union. This is the probability of x intersection y, which means the probability of occurrence of x and y, and is given by px dot py by x, which is also equal to py dot px by y. Now this is called law of multiplication of probability. Here px by y is called probability of occurrence of x given that y has occurred. This is also the 4th type of probability, that is called conditional probability. So conditional probability of x given y has occurred is given by probability of x intersection y, which means probability of occurrence of x and y divided by probability of x. Now this formula is called law of conditional probability. So that is it. These were the types of probabilities. Now let's move on to the next topic. So here we have Bayes theorem. Now it is an important concept and we will use naive Bayes algorithm that is based on this theorem in our modeling module. So let's see what Bayes theorem is. Bayes theorem is an extension to the law of conditional probability that we saw in a previous slide. It defines the probability of occurrence of an event related to any condition. It is given by the formula shown here. Now this is the general form of the formula, which means x can take multiple values, which means there could be multiple possible cases of x, and we want to know the conditional probability of any of the case given a certain condition. For example, there are 3 painters who have submitted their paintings in a competition, and we want to find the probability of one of these painters winning the competition. So here x can take value of any of the painter. Now from the general formula, we can also deduce the formula for special case for 2 events. And the formula for special case for 2 events is given here on the screen. Now let's understand this with the help of an example. Suppose you have planned to go to a picnic with your family, but you wanted to be sure if there will be rain or not. So first thing you checked is the forecast and found out that there is a 10% chance of rain. The forecast also tells us that the weather will be cloudy, and the chance for weather being cloudy is 40%. And it also says that 50% of the time the weather was cloudy when it had rained in the past. So now based on this information, you want to know the probability of rain on the day of your picnic given the weather is cloudy. So we can use Bayes theorem in this case as shown here on the screen. Here rain is our x and cloudy weather is our y. The formula says probability of rain provided the weather is cloudy is equal to probability of cloudy weather when it has rained, that is 0.5 in our case, multiplied by probability of rain, which is 0.1 in our case, and divided by probability of y, that is probability of weather being cloudy, which is 0.4 in our case. We will put in these values and we'll get the probability of rain when the weather is cloudy as 0.125. So that is how we use Bayes' theorem. Now moving on to the next topic, that is random variable. So what is a random variable? By definition, random variable is a set of possible values from a random experiment. And random experiment is the one whose outcome is uncertain. For example, we roll a dice. The possible outcomes here are 1, 2, 3, 4, 5 and 6. Now the variable x can take any of these values. Hence x is a random variable. We use random variables because in an experiment there could be n possible outcomes, and mentioning all the outcomes every time we use the experiment is not a wise thing to do. So we use random variable to denote the possible outcomes. Now the probability of the possible outcomes of a random variable is given by probability function. There are two types of probability functions: CDF, which stands for cumulative distribution function, and PMF or PDF. Now in the case of CDF, whether a random variable is discrete or continuous, it is given as fx is equal to probability of capital X, that is a random variable, being less than equal to small x, which means any value of x. Now it could be a uniform or normal distribution, etc. We will learn these distributions in the upcoming slides. We will also see one example of CDF in a while, but before that let's understand what is PDF or PMF. So probability mass function is used when the random variable is discrete. So PMF can also be derived using CDF. When the random variable is exactly equal to small x, then CDF becomes PMF. So here we find the probability of a random variable capital X being exactly equal to small x. So PMF could be a graph, equation, table, Poisson or binomial distribution. Then in case our random variable is continuous, so we use PDF, which is probability density function. Now it tells us the probability of a random variable capital X being not equal to a particular value of small x. Here probability at a particular point is 0. Again, it could be a uniform distribution, normal distribution, etc. Now let's see one example of each of these distribution functions. So first we will see CDF. Say in a group of students, probability is equal to 0.7 is found using CDF at x is equal to 80%, which means there is a 70% chance that a randomly selected student will have a score less than 80%. Remember, it gives us the probability of being equal to or less than x. So that is how we use CDF. Now an example of PMF would be, let's say a company sells 2 homes per day and we need to find the probability if it will sell 3 homes tomorrow. So here we can use PMF because we want to find the probability of a random variable capital X being exactly equal to a certain value of small x. That in our case is 3 homes. So here we can use PMF. And lastly for PDF, we use it in several places. And we will see this in our course throughout. It is used for any continuous variable that follows normal distribution, such as human IQ data, etc. So that was a quick brief about the probability concepts that we need to know right now. Let's move on to our next topic, which is distributions of a random variable. First, we will define what is a distribution of a random variable. A probability distribution is used to define random variables. It is a mathematical function that provides the probabilities of the occurrence of various possible outcomes in an experiment. The sum of all the probabilities in a distribution is always 1. Now there are various types of distributions, but we will restrict our scope to the following. binomial distribution, normal distribution, t-distribution or student t-distribution, chi-square distribution, and f-distribution. So let's quickly see each of these distributions one by one. The first distribution is binomial distribution. But before knowing binomial distribution, we must know what is a Bernoulli trial. Bernoulli trial is a random experiment. Recall, random experiment is any experiment whose outcomes are random. So Bernoulli trial is a random experiment whose outcomes are only of two types, say success S and failure F. The probability of success is taken as P, while that of failure is taken as Q, which is equal to 1 minus P. Now a Bernoulli trial repeated n times is called binomial experiment, and the distribution of it is called binomial distribution. Now there are four conditions that should be met for a binomial distribution. First is number of trials must be finite. Second, each trial should have exactly two outcomes. Third, trials must be independent. And last is the probability of success or failure should be same in each trial. Then the formula for binomial distribution is shown here on the screen. Here x is equal to number of trials up to n. Then p is probability of success. And q is the probability of failure, which is equal to 1 minus p. Then ncx is the combination and is given by n factorial divided by n minus x into x factorial. Now let's move on to the next distribution, which is normal distribution or Gaussian distribution. The normal distribution is a family of continuous distributions that can model many histograms of real life data, which are mound shaped, that is bell shaped, and are symmetric, for example height, weight, etc. Now this distribution is probably the most important distribution for your data science career because it is most widely and commonly used. The first property is that mean, median, mode are equal. Then it is symmetrical about the center. Then the total area under the curve is 1. Obviously the area under the curve is probability. So total cumulative probability will always be equal to 1. Then a special case of this normal distribution is called Z distribution or standard normal. And it is a very important distribution. Here we have mean is equal to 0. And variance or standard deviation is equal to 1. Then if you see, we have limits defined in terms of standard deviation. So 68% of the values lie between minus 1 sigma to plus 1 sigma. Then 95.5% of the values lie between minus 2 to plus 2 sigma. And 99.7% of the values lie between minus 3 to plus 3 sigma. Well, you must have heard of 6 sigma quality control technique. So this is what 6 sigma is, which says that 99.7% of the values will lie within minus 3 to plus 3 standard deviation. So that is what normal distribution is in brief. Now let's see how we can find the probability in a normal distribution. So to find the probability in a normal distribution, we will have to transform a normal random variable to a standard normal random variable by finding the Z-score. Then once we find the Z-score, we will look into the standard normal tables to find the probability. I'll show you how we can browse through the standard normal tables in the next slide. But before that, let's see what is the formula for Z-score. Z-score is given by this formula. Here x is the sample observation, mu is the mean, and sigma is the standard deviation. Now the next question is, once we find the Z-score, how do we interpret it? So a Z-score of 1 means that it is 1 standard deviation above the mean. A Z-score of 2 is 2 standard deviation above the mean. And a Z-score of say minus 1.8 is minus 1.8 standard deviation below the mean. Now once we have Z-score, we can find the probabilities using the standard normal tables. But before that, let's see how we can use Z-score. Suppose we have got the scores of a group of students. Now let's say the mean score of this group of students is 60 and the standard deviation is 15. Then let's say we have a student Sarah who has scored 70. So what does this number 70 tell us? Is it a good score or a bad score? Well, to be frank, it tells us nothing much except that Sarah has scored 70. But if somehow we can know that how many students have scored more or less than Sarah, then this number 70 will be meaningful for us. And yes, we can do it by studying the scores of all the students. But remember, studying the population is rarely possible. And we always study sample to derive the conclusion about the population. And that is the whole point of doing statistics. So here we will calculate Z-score from the above formula. And let's say it is coming out to be 0.67. And then we can look this value of Z-score in the standard normal table to get the probability. So when we look at the table, we get to know that it is coming out to be 25.14%, which means approximately 25% people have scored better than Sarah and approximately 75% have scored less than Sarah. So I hope you can see how Z-score makes sense. Now the same thing we can show on the distribution as well. So you can see here in the graph, 75% of the scores are on the left of Sarah and 25% are on the right hand side. So that is how we use Z-score. Now let's see how do we use the standard normal tables to find the probability using Z-score. So in our previous example, we found the Z-score as 0.67. Now we will look this value of 0.67 in the standard normal table. So this is a screenshot of a standard normal table. You can search it online or you can find this in any of the statistics book as well. So to find our value of 0.67, we will look in the first column and find the nearest value, that is 0.6. Then we will look at the top row and find the remaining value of 0.07. Now the value at the intersection will be the probability. And remember, that is what we found in the previous slide. Now interestingly, we can also use Z-score to calculate X at a given percentile. Suppose you have been given a Z-score, mean and standard deviation and are asked to find out the value at 70th percentile. Recall, percentile is a value below which a given percentage of observation falls. For example, 70th percentile means 70% of the observation falls below it and 30% lie above it. So we can use the above equation and we just have to find the value of X, and this will be our value at 70th percentile. Now let's move on to the next distribution, which is t-distribution or student t-distribution. Now the t-distribution is also a bell-shaped distribution similar to the normal distribution, but it has heavier tails. The t-distribution is used instead of the normal distribution when you have small samples or the standard deviation of population is unknown. The formula for t-distribution is given here. X bar is sample mean and mu is population mean. We have changed sigma to S, that is the standard deviation of a sample, and we also have divided it by the square root of n, which is the sample size. Now before we know how to calculate the probability using t-distribution, we should first know what is degree of freedom. So the degree of freedom refers to the number of independent observations in a set of data. There are different ways of calculating it, but we will calculate degree of freedom as n minus 1. Now back to calculating the probability using t-distribution. So here we will not go into details, but we can simply calculate the t-value from the above formula and use it along with the degree of freedom as an input to any t-value calculator. They are available online, and also any software that we are going to use can calculate the probability using the t-values. So the next question is, what does this probability tell us? Let's say we have a population of students with a mean of 100. Then we picked up a sample of 15 students from this population and found the sample mean as 110 and standard deviation as 15. Now by using the above formula for t-distribution, we plugged in the values of population mean, sample mean and standard deviation and calculated probability is 0.22. Now what does this mean? It means if we take another sample of 15 students, then there is a 22% chance that the sample mean of those 15 students will be less than or equal to 110. So that is how we can use t-distribution. Now let's move on to our next distribution, that is chi-square distribution. The chi-square distribution is a right-skewed distribution, and it is the distribution of chi-square statistic, which is given by the following formula. Here x is the chi-square statistic, sigma is the population standard deviation, s is the standard deviation of the sample, and n is the sample size. Remember guys, you don't have to learn all these formula by heart. I'm just putting it across so that you know the basics. We will not be doing these calculations anyways. Now we can find the probability using chi-square statistic and degree of freedom with the help of an online calculator or any software like R. And similar to our t-distribution, which gave the likelihood of sample mean being less than or equal to x, here the probability that we calculate will tell us the likelihood of finding the sample standard deviation equal to or less than s. So that is how we can use chi-square distribution. Now moving to the last distribution, which is F distribution. This is also a right skewed distribution, and it is associated with the F statistic. One common use of this is to test if the samples drawn from two independent populations have same variance or not. For example, suppose you randomly select 7 women from a population of women and 12 men from a population of men. And now you want to compare the variance, so you will use F distribution here. The formula to calculate F statistic is shown here. S1 and S2 are the standard deviation of sample 1 and sample 2, and sigma 1 and sigma 2 are the standard deviation of population 1 and 2 respectively. We can again find the probability using an online calculator and degree of freedom with the help of an online calculator or in software like R. Now with this, we have completed all the distributions that are required for us to know for this course. So let's move on to see few important definitions that are remaining in this section now. The first important concept is odds. Let's see what are odds. Suppose there are 8 games. Now what will be the probability of my team winning 5 games? It's pretty simple. The total number of ways it can happen or number of events in favor, which is equal to 5, divided by the total number of events that are 8. So it will be 5 by 8. Now on the other hand, odds are defined as count of something happening, means winning here, which is equal to 5, or you can say probability of winning, which is equal to 5 by 8, divided by count of something not happening, or you can say probability of losing, which is given by 3 by 8. So we will put these values and we'll get odds in favor as 5 by 3. Now if we put count of something not happening, which is equal to 3, or probability of losing, which is equal to 3 by 8, divided by count of something happening, which is equal to 5, or probability of winning, which is equal to 5 by 8, then the value that we will get, which is 3 by 5, will be called as odds against. Now these are the few terms that we will come across often. So I hope you have got the idea about it. Also, if you have noticed that here odds were expressed as counts as well as probability. But we will often see odds expressed in terms of probability. Now the next term that comes after this is log of odds. So we saw that odds in favor was 5 by 3 and odds against was 3 by 5. In short, we can say that odds in favor of my team will lie between 1 to infinity, and if odds are against my team, then it will be between 0 to 1. So these values cannot be compared because one value is lying from 1 to infinity and the other lying between 0 to 1. Hence, to address this problem, we take log. What log does is, it will make it symmetrical, ranging from minus infinity to plus infinity. It will be a normal distribution, and this is called log odds or log of the odds. Also, as we saw, odds can be calculated using count and probability. So when we use probability to calculate odds instead of counts, and then we take log of that probability, then log of odds is called as logit function. So that will be all from odds. Let's move on to the next concept. The next concept is confidence interval. Now we know that statistics is not an exact science. It's a guesswork. Now by guess, I don't mean it's a mere hunch, but it is a guess based on powerful calculations. So if it is a guess, we would want to know how good our guess is. Now how do we do it? We do it by calculating something called as statistical significance. So statistical significance are of two types: estimation and testing. Testing we will see later in the upcoming section. So we have a whole section for testing. Then the other one is estimation. Now estimation is nothing but what we have learned so far. It is basically using the information of sample to arrive at a conclusion about our population. In other words, using statistics such as sample mean, standard deviation, etc. to know about the population mean or standard deviation, etc. Now estimation, as you can see in the flowchart, is again of two types: the point estimate and the interval estimate. Now point estimate, as the name suggests, is an estimate at a particular point. But interval estimate is an estimate in the form of an interval within which true value lies. Hence the interval estimate is called as confidence interval. Now as I said, that confidence interval is computed from the statistic of the observed data that might contain the true value of an unknown population parameter. For example, a 95% confidence interval is a range of values that you can be 95% sure that it contains the true mean of the population. Now confidence interval is given by this formula. First is the sample statistic, such as mean, standard deviation, etc. of the sample, plus minus margin of error. Now margin of error is given as m into standard error. So m is a critical value here. You can use either t-score or z-score. And standard error is the standard error of the sample statistic, means standard error of the mean or standard deviation, etc., for which we are calculating the confidence interval. Also, the center of our interval would be the point estimate. Basically, the sample statistic that is shown here is the point estimate. So here I have shown a normal distribution curve with a confidence interval of 95%. It is showing the value of x between 100 to 125. And it will be less than 100 only 2.5% times, and greater than 125 only 2.5% times. So if we see the value of mu that is given here, it is the population mean, and it is equal to 112. And the value of x is between 100 to 125. So we are 95% certain that our population mean will lie between this range. So this is what confidence interval tells us. Now the next important concept is population proportion. So sometimes we don't use mean of our population for our statistical process and instead use population proportion. A population proportion is a fraction of the population that has a certain characteristic. For example, a poll of a particular candidate might show that she will get 40% votes. Or a company making products for car might be interested in the percentage of people who owns a car in a country. So all these are examples of population proportion. Now the next important question is, how do we get to know if it is a problem of population proportion and not mean? So the first condition is that the distribution is binomial distribution here. And secondly, there is no mean or average mentioned in the question. So that's how you can know if the problem given here is a population proportion problem or a problem of mean. Now let's see what are the formulas for population proportion. So let's say x is a random variable following binomial distribution. Here n is the number of trials or sample size, and p is the probability of success. Then we have p hat is equal to x by n, Standard error is equal to square root p hat into 1 minus p hat divided by n. And z is equal to p hat minus p naught divided by standard error. So here x is the number of items you are interested in. Say in a product survey done on 100 people, 40 said yes to buy it. Then x will be equal to 40. P hat, Q hat are the estimate of population proportion P, Q, which are unknown. So P hat is equal to estimated proportion of success and Q hat is equal to estimated proportion of failure. And P naught is equal to hypothesized population proportion, which will be given in the question. So that is what population proportions are. Now let's move on to the next topic, that is central limit theorem. Now this is a very important, or rather a central concept for a data science career. So let's see what the central limit theorem says. The central limit theorem states that the sampling distribution of the sample means approaches a normal distribution as the sample size gets larger, irrespective of the shape of the population distribution. So all this is saying is that as you take more samples, especially large ones, means greater than 30, your graph of the sample means will look more like a normal distribution. So as you can see in the graphs, as we are increasing the number of samples from n is equal to 1 to n is equal to 30, our graph is approaching a normal distribution. This means if we take larger samples and average the sample means from all the samples, or average the standard deviation from all the samples, then it will be a representation of population mean or population standard deviation. So this is what central limit theorem states. So alright everyone, we are through with the second section, that is probability and distribution of our first module, basic statistics. Now let's quickly see what we have covered so far. We started with the probability concepts, where we discussed sample space and events, methods of assigning probability, types of probability, Bayes theorem, then probability density functions. Then we have learned different types of distributions, binomial distribution, normal distribution. Then we saw ZScore and its use, then T distribution, chi-square and F distribution. After that, we learned few important concepts such as odds, logic function, confidence interval, population proportions, and central limit theorem. So guys, I know that there were a lot of theoretical concepts that we have discussed here, but see, we are only learning what is required for our use. And I'm trying to present all the ideas in the simplest forms. So just hang in there. You're only left with one more section, that is hypothesis testing, and then we'll be over with our first module. So I'll catch you up in the next video, but make sure to like the video, subscribe to the channel, and share it with your friends. So until next time, take care and see you.